Okay, good afternoon, good evening, good day from wherever you are watching us from. Welcome to Niger Data Community Training Series. We are on week 8, and today we'll be looking at work with Delta Lake tables in Microsoft Fabric. So we are going to be using the Microsoft Learn for this today's training. So you can do a hands-on follow-up with us as we go along in the training. So today, my name is Anna. I'm going to be facilitating today's session. So our learning objective for today, we are looking at understand Delta Lake, create Delta tables, work with Delta tables in Spark, use Delta tables with streaming data, understand Delta Lake. So Delta Lake is an open source storage layer that brings reliability to data lakes. So Delta Lake is ideal for organizations dealing with large scale data lakes. So it ensures data consistency, reliability, and efficient management. So the tables in the Microsoft Fabric Lakehouse are Delta tables, signified by this triangular icon that you can see on the tables in the user interface. You will see the embedded triangular icon on the grid table lines that you can see now on the screen. So in summary, Delta Lake is a powerful tool for managing data, ensuring data quality, and enabling advanced analytics. Create Delta tables. So basically, we have two types of tables in Delta Lake. We have managed table and external table. Managed tables are tables where Delta Lake manages both the metadata, the table definition, the schema, etc., and then the underlying data files. The metadata and data are stored within the Databricks cluster. That means the metadata itself, and then the data, they are stored within the Databricks cluster. Relocation for managed table, they are inside within the Databricks cluster, and they are less adaptable for integrating with external tools. Their scalability, they have limited scalability, and Databricks manages their metadata, including the maintenance and backups. For data governance and control, they conform to the database governance model, since it is being managed by the Databricks. For external table, their metadata is managed by Delta Lake, but the underlying data files are stored outside the Databricks cluster. Their location, so you have to specify the location of the external table. For location, the characteristics of external table, they reside outside of the Databricks cluster. Flexibility, they are more adaptable for integrating with various tools. Yeah, scalability, yes. External tables can accommodate the requirements of massive data warehouse. For maintenance, they require independent maintenance and backups, just like, since it is being stored outside the Databricks cluster. So for governance and control, external tables uses a separate governing process. Key difference: when you drop an external table, the underlying data files remain intact. You are expected to manage the data files. In contrast, when you drop a managed table, that means you delete the table, the metadata and the data gets wiped out. So basically, you can then choose the appropriate type of table you want to use based on your organization's needs, considering the factors like your scalability, governance, and control. So for more details, you can refer to the official document. Using Spark SQL. So the most common way to work with data in Delta tables in Spark is to use Spark SQL, or you want to write it in Python. So for SQL, like this command on the screen is a SQL command update, which modifies the content of the data in the table, setting the price to a particular amount, where the product ID is equal to 1. Use the Delta API. So when you want to work with data files rather than catalog tables, it may be simpler to use the Delta Lake API. You can create an instance of a Delta table from a folder location containing files in the Delta format, and then use the API to modify the data in the table, like you see the update the table, reduce price of accessory by 10%, create a Delta table object or that you see on the screen. Use time travel to work with table versioning. So modifications made to data tables are logged in the transaction log of the table. So you can use this logged transaction to view the history of changes made to the table and to review older versions for the data known as time travel. So to see the history like what we are looking at on the screen, we can use the describe SQL command to do that for us to see the history. And what we can see the version 0, under version 0 in that row, we can see that the operation type was create. So they were creating table was created. In version 1, we write, the operation was write, and then which is used to like append add more data to what you have in the already have in the table. If you add one more row, and then the second, the number 2 version, we can see they use the update command to like modify table. So what we see the version is you see the time travel to work within the table and the version. Spark structured streaming. So all of the data we have looked up to this point, has been static data in Quaz. However, we know in current dispensation, many data analysis scenarios now involve streaming data that must be processed in near real time. So, for example, you might need to capture readings estimated by Internet of Things devices and store them in a table as they occur. So a typical streaming process, like you can see on the screen, you have the input stream and then the output stream, and in between you have the processes, that is ongoing. So it involves constant, excuse me, constant reading, reading a stream of data from a source, uh, optionally processing it to select specific fields, aggregate and group values, or otherwise manipulate the data and writing the result either to a table or to a scene, as the case may be. So thank you very much. At this point, we are going to switch to the browser where we are going to take the exercises by Microsoft. So while I try to share my screen, I will suggest you also open up um, your browser, get on your PC, so that we can study together. Okay, so here we are on the Microsoft Fabric environment, and on my right I have the Microsoft Learn, like we shared during the course of our presentation. So we are going to navigate to data engineering by clicking on this Power BI icon, and we click on data engineering. So when we get to this environment, we are here already. So the first thing we do is to create a workspace that we are going to be working on. So let's give it a name. Okay, so we apply. You can give it a logo if you like and description if you want to, but we just want to keep it simple. Okay, so we don't have anything here yet. So with that, we are going to create a lakehouse where we'll be working on. So select lakehouse. And then we give it a name. I think we should maintain the same name, lakehouse. So here we have the tables, we have the files. So what we need to do now is to, they are empty. So we are going to follow the Microsoft Learn exercise to get started. So with that, we are going to, we have already done this part. So the next task for us to do now is to download the file, which I have already downloaded. So what we need to do is to go ahead and create a subfolder that will be holding that file. So let's create a subfolder. So we hit on our file and we create a subfolder where we are going to bring in our products. So let's type in products. We can either type it in or select it because I have that, so it's showing it on the. Okay, so now I have a sub folder showing products. So next we'll do is to upload the files into that our CSV file into this folder. So click on the services, click on upload, and we say upload file. So I hit this folder to get it from where it is. So this is the CSV folder and CSV file. So I click on upload and the file will be uploaded for me. So it is that simple. So here we go. We have the file. So we can preview the file here. So this is what we have, which is the same as what we have it in our CSV file. Okay, so next assignment is for us to create tables like we did in our presentation. So we are going to, before we create a table, we want to describe this same file that we're seeing here in a data frame format. So with that, we are going to describe it in a data frame format. So before we do that, we are going to create a new notebook. So we can create a new notebook that we will be using to create our code. So, yeah, we can give our notebook a name. Let's call it, can give it any name, actually. Um, um, let's see. Okay. No, let's say learn notebook. All right, so this is a notebook. So this is the notebook where we can write our code. We have two types. We have this code. If you click on this plus, a new cell will be created, which is basically for writing code. And then we have this markdown. You click on it, it will also create a new cell where you can do documentation. So let's take them up. You can use this delete button to delete the cell that you don't want. So let's go back to our lakehouse and then we'll go back to our products. So here, if we click on this ellipsis, we can use it to load the Spark code that we talked about during our presentation. So let me collapse this. So we can see the code. So this is the code. Basically what it does is that I'm writing it as a data frame. I'm reading it and then in the format is CSV, as reading form, and it will have a header that is true, and it's loading it into this lakehouse. Okay, so if we run it, Depends on your data, the likeness of your data. Okay, so I think it's ready. So this is our data frame. So we can see that it's in the right column, product ID, column name, category, the prices. So it's well separated and readable than the one we loaded from the CSV earlier on. So we can now go ahead to the next step to create a table, which is creating delta tables. And the first to be created is manage table. So we are going to click on a new cell so that we can write our code, and we can just copy this code and use it in our demo. So we can run the code. So basically what is happening here, we are writing, again, is data frame like we explained earlier. We use write to create the table, and then we use save as table to save it as what? As manage products table. So that is basically what is happening here. Okay, so yeah, so it's done. So like we explained it during our presentation, that the triangular icon is showing. So when you see it on it, you know that, okay, this is our delta table. So let's go ahead and create a new, and if we click on it here, we can see our header that is showing the product ID, product name, and the list price category. So we know that, okay, it is done. So we can go back to our notebook and create the second table. We mentioned two types of table. So we have seen the manage table. Now we want to look at the external table. We can as well copy the code here and use it in our. So when we were explaining the differences between the manage and external table, we said we need to define the path, the location where this external table is going to be stored. So we want to define the path of, so we just copy the path and replace it with what we already have here. So basically it's the same thing with what we did, the same code. It's just that here the difference is just that we are specifying the file location we want the external table to be stored. Okay, so if I refresh my table as well as my file, like we said that for external tables, the table will be created and we'll also have the data in the file. So we have it. Sorry, I was not supposed to do that. Okay, so we can see the data log we mentioned and the packets that has been created by the external table. That's what I wanted us to see. And then, of course, the table is also created here under our table. We can see the delta icon, so it shows that it's a delta table. We have the product ID, product name, category, and list price. So yeah, So, and let's go to our lakehouse and let's see. Sorry, for external table. Let's hold on for a second. I think it's going to take a while. Actually, wanted to look at the manage table to reasons there because since the external table is stored outside the Databricks cluster, so we can see that we have the same data that we saw earlier when we use the Spark to load from the products.csv. So we can see that they are the same. That's just what I wanted us to see. So let's get back to our notebook. So for our notebook, yeah, I wasn't supposed to rerun that. So let's get a new cell and if we expand our table, we see our external and my table. So though it's not in best practice, but just to demonstrate what we have, we said we want to describe manage table. We use describe command to see the format, though we have seen it in the lakehouse. Let's see, we can use that to describe the management. Okay, so we can see. So describing the table, we can see what is, it shows the number, the index, we have the columns. The columns, we have product ID, product name, category, list price. And we can see the data type is string. And then the comments, there's no comments. And then detailed table. So we want to see the details of the table. We can see that the name is catalog. If I click on this, I'll be able to see here on this side the catalog is in catalog Niger Lake House managed products. So that's then we can see the location where it is and what type of table it is. It's managed table. The provider is Delta, so we know it's Delta table. So and we can as well describe that of external table. So let's use this code to describe our external table. Yeah, so we have our external table described here as well. The same thing, product ID, product name, data type, string, no comments. The name, of course, the type is external, the location where it is being stored. So maybe we want to look at the location. So we can see the location, where the location, Niger Lake House, files, externals, product. So it's on a file. So then the provider is data, so it's a data table like we have seen. Then the table property. So with that, we have been able to see the difference between the manage table and external table. The external table has a table and also has a file, and then we have the manage table. So now we want to try and delete the table to confirm. We said during our presentation that for managed tables, they will be deleted and completely wiped out. But for external tables, the table will be deleted, but the external file will still remain intact, which you can, for managed and a kind of create a table, out of it. So let's try and run this table. All right, it's saying no data available. So here we have can see data. So let us refresh our table. We also refresh our file. Okay, so now that we have refreshed, everything is gone. Or you can see, just like we mentioned during our presentation, the external products is still intact. So the next assignment that we have is to create a SQL, use SQL to create a table, and we are going to create from these products, that's external products that we have. So let's open a new cell, and then let's copy our code. So we are just saying create a new table, use the delta table, and the location is here. This is the file location. So that's basically what we are saying. So we now run this cell. Okay, so if we now refresh our table and we expand, yeah, so now we have our products, data table products. So we can see, just like we and during the presentation, that we can create a table from it. So that we have done. So now let us try and like we want to list what is inside this product. And the command we can use, the SQL command is select star from products. That is the command we can use to. So we use the command. We hit on our run button. Okay, so if we scroll down, we can see we have, so it means that our table is correct, just like what we have earlier. We see they are the same. So this is very good. It's looking nice. So let us scroll down. So we create a new cell. And this time we want to go to exploring table versioning. We made mention of it during our presentation, where we saw version 0, version 1, version 2, so let's use, we want to use this code to see different version. So this code, we want to use it to update, to modify this table that we have just looked at. So when we modify it, we will now check. So the update will update the product table, and it will set the list price to implement a 10% reduction on the price where the category, this is the category, not all, it is not affecting all of the rows that is in this table. So there's a specification, a category where this price reduction is going to affect. So let us run the code. Okay, so we can see that it's done, and it's the number of rows affected is 32 rows. So basically, those are the rows that contains mountain bikes. So going on, let us now describe the history. We said the other time we can use describe so let's describe the history of the product. So let's get a new cell, and then we want to describe the history. Okay, so we can see the versioning, right? So here we have 1, 2 rows. The version is, we have version 0, we have version 1, and then we have the timestamp, the time taking, and you can see the username. This one, an update is done. The version 0 is where the table was created. So with that, I think we saw this during the course of the presentation. So we can see it live. So we can generate another code cell. This is cell code. We'll want to, let me grab this and the code. So here we have the data table path that is showing the external table, external products in the file. So here we want to get the current data. Like I said earlier, before our exercise begins, we said we can use this as our comments. So this is, we are getting the current data. And when we get the current data, what do we do with it? We want to read it using Spark Read. I will want to format it, as Delta. And we want to load it to our Delta table path. So here we want to get the original version and to read the format as Delta, So let's run this code. Okay, so looking at this, let us see. We can see this was our update version that we did earlier when we updated that affected 32 rows. So we can see that the price reduction was reduced by 10%. So the price has changed. And then if we move down to our original, we can see the original price when the table was created. This is the version where the table was created. We can see the original price. So this is how we can, do manipulation of with that data, whatever you want to do concerning your your data depending on your organization demands, So now we want to go into streaming data. So at this point, I guess let's get a new okay, let's go on. I had wanted us to get a new notebook, but it's fine. We can go on still on this page. So let's get a new cell and then we can look at it. Here we want to look at streaming data now. So let's get this code. On which cell? So basically we want to excuse me, we want to create a folder. We want to input the path like we described that the input path will create and the files a data folder where you can always watch out for the new files that are coming in. And here we are creating this stream, reading the stream using the schema, to read into our devices, our IoT. And here we write the events, and you will be able to see all of the events. So let us run the code. Okay, so we can see a source stream created. So so we can see the data folder that we were talking about. So this is the data folder, and that has been created, for us and lifted. So I just wanted us to see that before we move on. Okay, so that's the folder that's I can always watch out for what's the new files that will be coming into. Let me see if I can do something. Let's see if we can see web URL. Sometimes it usually take time, but I don't know if it will open up. If it doesn't, well, fine. Okay, it's loading. All right, so here we are. You can see all of the jobs. Excuse me. So we can see the duration, the time taken, succeeded, completed jobs. Okay, so let's go on and let us write to that. Basically, we are writing to streams, so like we are So let us run it. I hope we didn't skip any of our exercises. Yeah. Okay. So it's done. So again, if we check, we'll see the time taking. So when we write to streams, if we keep writing to stream, it will keep adding to what we have. So let us see what we have. Yeah, so we can see that what we have written is 9 rows. And if we decide to write to stream again, we have 9 rows. So let us note that by the time we write more to stream, we are going to have more rows. Let's go back to our notebook. I think something happened there. All right, so we are just adding more to what we have written earlier. So like append, like your normal append command that we are used to. So let's run the code. So it's true, so it's done. So let's also try to use the select command to see the number of rows that we now have. Here we go, we now have 16 rows. So originally we are having 9, and now we have additional rows added to it. So this is how you can write to stream, and if we continue, it will just keep adding. Let me see if we can see anything here. Okay. Okay, so like I said, if we don't stop the stream, it will keep adding. So what we need to do is to, when we are done, we have to stop this stream. So we issue a stop command and we run it. So with this stop command, the stream has stopped. And then if we try to run this again, it will not add to it because we have given a command to stop the stream. So basically that is all that we have. The last step that we have is cleanup. So if you are just to clean up, we can, remove workspace. So what we can do is to go to our workspace, and if we go to our workspaces and we navigate to Nigeria workspace, and we click on workspace setting, it will open up our workspace setting, and then we click on others, and then we remove this workspace. So that is the end of the exercise. I hope you enjoy it, and if you have any question, any concern while you are trying to do the demo, you can always drop your comments and questions. There'll always be experts on our website that will always attend to you. Thank you very much for listening. Have a great day and have a blessed weekend. Bye for now.